Awesome. Welcome everybody to today's webinar, What's Falling Out of Your Wallet? Understanding S3 Bucket Vulnerabilities in Light of the CapitalOne Breach. I'm reading the full title for the audio only version of this, which doesn't exist yet, but who knows, down the road we may do that. I expect today to be a fun deep dive into the technical analysis of the CapitalOne breach, which really isn't quite as complicated as some people have made it out. But then we're also going to spend quite a bit of time talking about S3 buckets, what that means, what permissions are all about, why do people keep having a problem with this, and probably the most important part, what can you do about it in the future? So before we get started, just a quick thing, if you're not familiar with Secure Ideas, we've been around for about 10 years. We do provide a variety of security consulting services to a wide variety of clients. We work in virtually every industry, mostly in the US, but occasionally outside the US as well. So if you have any security opportunities or concerns that we can help with, please reach out. We'd love to have a chance to work with you. I'd also like to put just a quick introduction to some of our upcoming webinars. We're trying to ramp up some of our public education that we do. We do a lot of training, but trying to give back to the public and do some education-based stuff. We're going to be doing one called Summertime Blues, how to keep Bluekeep from ruining your vacation. That's with Eric, the assassin of Active Directory, the destroyer of domain admins, Keen. Eric knows more about Active Directory than anybody I know, and so we give him a hard time, but that's going to be an awesome session. Also, Alex Rodriguez is doing one called The Empire is Dead, Long Live the Empire. And he's going to dive into, with the recent announcement that PowerShell Empire has been end of life, effectively. He's going to look at several of the new C2 frameworks that are out there and just kind of compare and contrast, what's the next big thing that attackers will want to be using. We also have a paid webinar. We do these occasionally. It's a 2-hour webinar. It's only $25. So pretty easy on the pocketbook, but it's Tactical Burp Suite 2.0. This is with Kevin and Jason. They're going to jump in and really demonstrate how we use burp during a pen test. And if you're fairly new to web app pen testing, or if you've been doing it a while, that's definitely a course that's worth checking out. And then last, if you're in the market to get your CISSP, check out our mentor program. It's kind of a middle ground between, hey, I'll buy the books and do it myself, versus I'm going to pay $7,000 to go to a boot camp for 7 days. This is a 9-week program. It's still a lot of self-study, but we have a 2-hour webinar every week, and we have a Slack team and people dedicated to kind of help you get along that process. So if you're looking at getting the CISSP this year, definitely check this out. It starts next month, and you'll want to get started. So with that, just a little bit about myself. My name is Nathan Sweaney. I'm one of the senior security consultants here with Secure Ideas. Been with the company almost 7 years. Do a wide range of things, pen tests, training, etc. In past life, I've kind of had a wide range of experiences with smaller companies doing DevOps stuff, some sysadmin stuff, got into networking, more dedicated. I'm one of the primary organizers for B-Sides OK. So if anybody's in the, I'm also the only Nathan Sweaney in the world. So if you can spell it right, you can Google me, and my life's pretty much an open book. But there's my contact info and my crew of hooligans there on the side. So the goals for this webinar, we want to understand S3 bucket vulnerabilities. We're going to talk a little bit about what S3 is and how it's vulnerable, or how it can be vulnerable, specific things that people do or don't do. We're going to explore specifically the 2019 CapitalOne breach. Yes, I did specifically put 2019 in there because as more and more breaches continue to happen, I've realized it's no longer safe to say the company X breach, because unfortunately many companies are getting hit more and more repeatedly. And so now we hopefully we don't get to the point where we have to say the August 2019 or the July, whatever. And then at the end, we're going to outline some security controls, specifically some things that would have helped CapitalOne and prevented this, but then also just some general security controls that, hey, if you're using AWS, if you're using S3, these things will apply. And I'll be honest, the the controls that we're going to talk about and really the vulnerabilities aren't necessarily specific to S3 and to Amazon. Some of them are, but a lot of the same concepts, you know, apply to Azure. They apply to IBM's cloud. They apply to Google, you know, whatever you might be using out there. So some good stuff. I didn't mention earlier, but if you have questions, please throw them in the chat down in the bottom right-hand corner. I will try to monitor that. It may come up, Andrew's going to help me with that as well. It may be a question that I need to put off till the end or take offline later, but as much as possible, I'll try to answer those as we go. So please feel free to jump in and collaborate on that. So understanding S3 vulnerabilities. What the heck are we talking about? What is S3? I'll be completely honest. For me, when I first started hearing about AWS and Amazon and S3 and EC2 and all these acronyms, I kind of had this like, I don't even know what to call it. It's not a paranoia, but like I became frozen, right? Like I couldn't move, like all these acronyms, I don't want to dive in. It just sounds really complicated. But once you actually start using it and start figuring out what we're talking about, it's not that complicated. I mean, it's a slightly different technology. There are a lot of gotchas and things to consider. But the whole concept of the cloud and hosting stuff in the cloud and all the different services and whatnot, it's pretty accessible for most people, especially if you don't mind reading a little bit of documentation. So an S3 bucket, in completely simple terms, it's a folder or it's a directory. Amazon calls it their simple storage service. That's where S3 comes. They even say simple in the name, right? It's AWS's version of, you need a hard drive to store some stuff. We're going to give you a big hard drive to store some stuff. Oh, and we're going to add in a whole bunch of features to it as well. You know, there's some advantages to it. It's extremely low cost. It's extremely durable. I had to count this, 11 nines. I've never even seen that before. You know, people brag about 4 nines and 5 nines in reliability. But 11 nines is just insane. They also have several classes of storage. And what that means is, you know, there are some types of data that you need more accessible. You're going to interact with it more often. You know, it needs to be faster and maybe have a little bit more features to it. You have other types of data. You know what? Hey, we're going to do this backup every 6 months, and it just needs to go off in cold storage. And hopefully we're never going to have to look at it. So we don't want to pay as much for that. So there's different levels of storage that you can pay for with S3. But you know, it's all optional. You know, to get started with it, you don't need to understand all that. You can start with the default and move on. There's also neat features like lifecycle management. So, you know, we can say, you know, hey, this data, something needs to happen to it after a certain period of time. We're going to move it over here. There's different configurable options there you can do. So there's a lot of neat stuff that that AWS has introduced for not just for enterprises, but really for anybody who wants to build a really robust application or system. Part of the problem with that, and what we're going to see here in a little bit, is that all of these features really require a pretty fine-grained ability to set permissions. You know, hey, this particular system needs to interact with that system, and so we need permissions, restricting and governing how all that has to happen. So we're gonna dig into that a little bit later. When we talk about permissions, overall S3 is pretty secure by default. The screenshot there on the right of you know, creating a new bucket, and remember, bucket, we're just talking about a folder or a directory, if that name makes it easier to think about. By default, nobody has access. When you create this bucket, you, the owner, you have access, and nobody else. I mean, even your access is fairly limited. In order for anybody else to have access, you have to specifically assign it. You have to specifically give them read access, write access, etc. This includes other accounts. So if you have a server, an instance, you know, when we talk about EC2, EC2 is Amazon's acronym for basically another computer, a server. If you want to create a user account that server is going to have access to this bucket, you have to create that account and you have to manually assign access. If you have an application that needs to connect and store data here, you can create a user role for that application and you have to manually assign access. So there's a pretty significant amount of security by default. The other thing that's worth noting, and this is maybe the most important, down at the bottom on that screenshot, you see where it says manage public permissions? It says do not grant public read access to this bucket, recommended. What that means by default, every bucket is prevented from being accessed by the internet. Unfortunately, people change that without really understanding the context sometimes, or the controls around there, but at least by default, it's set up well. Now, here's the thing, outlining permissions is hard. This is not just true of S3 buckets, this is true of anywhere we store data. I don't know how many penetration tests we get in. I'm gonna say, I'm tempted to say 100%, but I'm guessing we have one client who's done this well. So I'm gonna say like 99% of the tests we do, we bounce around, we maybe all find stuff, we maybe not. The last thing that if you can't find anything else, the thing that's always there is open file shares. It's really hard for organizations to manage their file shares and keep track of which specific users should have access to which specific systems or data. A lot of times people will put some pretty good controls around things like the accounting data or the HR records, maybe executive shares and stuff like that. But if you're within that grouping, you pretty much have access to everything. Or they'll have like the open share that everybody has access to, and then they have people posting stuff in there that shouldn't be. A lot of times we see, hey, so-and-so left. We don't know what to do with their stuff in their My Documents folder. We may want it later. We don't want it, overwritten. So let's just copy this into this file share, and then we'll get to it later. And nobody ever goes through to find out, what kind of sensitive data is actually in that document or that list of documents. So this is a hard problem. What makes it more complex with S3 is that we're taking this thing that's already difficult to secure and we're putting it out on the internet and we're making it a little bit more accessible to the public, right? For somebody to get into your internal file shares, they have to get through your firewall, they have to access your stuff. For the most part, when we have stuff in AWS, we're already letting people through, think of it like a DMZ, like we're letting people in to some degree into our internal stuff so they can access our servers. They're just one step closer to those file shares. Another thing, and we're going to talk about this in a little bit more detail after we talk about the CapitalOne stuff. There's a huge list of possible permissions you can set up when you create all of the different Amazon services and the different user roles and all this stuff. A lot of people, when they're trying to figure out how do I make this work, they start by giving it a wild card. They say, you know what, let anybody connect to this, or let these users have any level of access to this. And as we know, as you can imagine, wildcards tend to be a pretty significant problem. So we're going to see a little bit of why how that plays out. Part of the problem with anything related to security is the whole security versus usability thing, right? The more secure something is, the less usable it is. The more usable it is, the less secure it is. I've seen a third version of this that has cost included. And so, if you spend enough money, you can get strong security and usability, but it's a balance there of trying to figure out. And that's true of any technology, but especially of technologies that develop quickly. And, the whole cloud thing has really kind of, it's been around for a while, but it really kind of took off quickly, and it's caught a lot of people off guard. With that throws us into this concept of, hey, we have all this stuff out there. What are we going to do about it? Who's attacking it? What's going on? Chris Vickery, I've never met the guy. He seems like a nice guy. I'm sure he's great. He's probably got kids and plays at the park, and is a wonderful man. He has become well known for discovering S3 bucket breaches. I have a picture of a baby seal here, so Chris versus the baby seal. I figured that's better than posting a picture of somebody clubbing a baby seal. But basically, all of these people started rolling out, all these companies started rolling into AWS and saying, hey, let's migrate our stuff, let's throw stuff up there. And they didn't really understand what they were doing. They didn't have the same level of controls in place that they had for all of their internally hosted stuff. And so what Chris and some others have done is said, you know what, we can actually search for these accessible S3 buckets. We can find stuff out there that's been made public or that has weak permissions. We don't necessarily know right off whose data it is, but we can search for it. And then once we find it, we can dig through the data and we can figure out and say, hey, I just found your data. This is a pretty bad thing. What are you going to do about it, kind of thing. And so we've seen just a ton of examples of this. this is just a partial list. This is not complete by any means, but this is a partial list of some of the S3 bucket breaches we've seen over the last couple of years. You see some pretty big names there. Booz Allen Hamilton, military contractor. Deeproot Analytics, that's one of those companies that nobody's ever heard of, but they gather a lot of voter demographics and sell it back to the political parties and campaigns and stuff like that. You see Time Warner, Verizon, the Pentagon actually had S3 buckets where I believe the intelligence there was related to social media posts from people that they were keeping track of and monitoring and stuff like that. That all got released out with an S3 bucket. Some Facebook partners, some of their third-party contractors lost 540 million records of user data. So much stuff. GoDaddy, Reddit, just tons of stuff. You see this thing. Now, one thing that you will notice is look how many of those were in 2017. That's right after I mentioned Chris Vickery. That's right after him and some of these guys figured out, hey, we can start brute forcing all of these buckets and we can start searching for poorly configured buckets and find stuff out there and then see whose it belongs to. So in 2017, we just saw this huge rash of, you know, all of this stuff happening and all this stuff coming out. We still see it happen occasionally, but it's a lot, it's a lot rarer now for that to happen. We find them less often. So that's a good thing. We're definitely getting better, but we still have some work to do. That brings us to CapitalOne. The CapitalOne breach was different for a couple of reasons. One, let's just kind of set the stage here. You know, if you were sleeping under a rock, didn't know what's going on, CapitalOne last month announced a data breach. They lost 100 million credit card applications. Think about what's on credit card applications, right? Like if you've ever filled one of those out, you know, they've got all of your information that is pertinent to your financial health on there. They also had 100,000 social security numbers. I saw one record said they had more than 1 million Canadian social insurance numbers, which is similar to a social security number. What's the exchange rate? Canadian social insurance is like 1.3 social security numbers. I don't know what the current rate is, something like that. But what was different about the CapitalOne breach is that it wasn't simply a wide open S3 bucket. It wasn't a bucket that was open to the public. They had put some efforts in place. They had learned the lessons of other people. They had some security controls there. What was different about this one is that it was a combination of an application flaw in their web application, in some web application. We don't quite know the details on that. And some S3 permissions that were a little too lax. Notice I'm not saying they were wide open. They definitely had some permission issues, but it wasn't as bad as what you would maybe expect if you were looking at this. Fortunately, we actually know quite a bit about what happened. We don't know all the details yet. There was a federal indictment, and I think it was like 12 pages long. I've got a link to it at the end of the slides, where they go through and outline some of the details when they're indicting the individual attacker. We also know the person that was named in the indictment. They bragged about a lot of what they were doing on Twitter. They posted some stuff on their personal GitHub account with CapitalOne data. And then they, I hate to say it, they have an internal Slack that they maintained, and they thought, hey, this is safe. It's my Slack. Nobody else has access to it except my friends. I'll post some stuff there. And yeah, obviously that didn't work out super well for them. So let's jump in. The next section where I kind of want to walk through and just explore this breach, explore specifically what we know happened, and kind of how this all played out. And hopefully, as you're walking through this, you're thinking about, if you've got folks or if you've got systems in AWS, you're thinking through some of the ramifications of like, hey, could this apply to me? And what do I need to do about this? And you know, what areas of concern do I need to maybe tighten up our ship a little bit? So this breach started, we believe, and I want to be very clear, this is an assumption, but I believe it's a well-founded assumption. This believed with a server-side request forgery attack. Server-side request forgery is one of those attacks that people kind of blew off for a long time. The concept was thrown out maybe a couple of years ago. Even internally at Secure Ideas, like we've seen situations and we're like, yeah, what's really the risk here? I don't know if this is a huge thing. In this particular situation, well, let me describe an SSRF attack the idea. So as an attacker or a legitimate user, you make a request to a public web server, something that's out there on the internet. That server accepts your incoming request because you're a normal user, and then it processes it somehow. It does something. In the background, in that processing, maybe it makes a request to another system. Maybe it needs to verify some data. Maybe it needs to make an API call. Whatever it needs to do, in the process of processing your request, it contacts another server. So in this instance, in our screenshot here, that public web server is connecting through the internal firewall to an internal web server that's not accessible to the internet, and then returning, maybe it returns something, maybe it doesn't. It's possible that public web server, all it's doing is sending data. Maybe it never gets a response, or maybe the only response it gets is an okay. In some cases, SSRF is able to make a request to an internal web server and then retrieve the result back through the public web server. But that's not always the case. Sometimes all we're doing is making the request. So that's basically what SSRF is. Here's an example. I actually saw this just 2 weeks ago at a client site. They had a situation where I could make requests to a web server, and as part of the request, I noticed that there was a domain for an internal system listed. And so I started poking at that and playing with that, and I used Burp Suite Pro and playing with some of the tools in there. And we discovered that if you change the domain, nothing changed in the response I got back from the server. But if I put the domain name of a system that we controlled, then it made the DNS lookup on the back end. So for instance, in this particular case, we own securideas.com. If I sent a request to this public server, and inside that request I had the domain name of some random string .securideas.com, I could go back and look at our DNS server, and I would see the request for that random string .securideas.com. What that tells me as an attacker is that public web server is doing something with that domain. It's parsing the domain name, and then it's making a DNS request outbound that is recursively going back to our DNS server that we control. Because of that process, I know I have a little bit more control over what's happening internally. In this situation, this is a really rare attack. We were able to discover a SQL injection flaw on that internal server that we never could have discovered otherwise. Like the response we got back from the web server did not include any evidence of SQL injection. But what we did is we used SQL commands to concatenate strings. And so we said, make the SQL connection and then do that random stuff. And we had that in a string, and then we had .securideas.com in another string, and then we used SQL commands to concatenate those. And then if it parsed correctly, it would make the request back to our server. If it didn't, we wouldn't notice anything. And the fact that it did parse correctly, it made the request back to our server. That told us not only is it connecting to us, but it's connecting from within a SQL server. So we had SQL injection via that method. So SSRF has really stepped up just in the last, for me at least in the last month. It's really stepped up in one of those vulnerabilities that people need to pay quite a bit of attention to. All right, so let's move on and talk about what this looked like in CapitalOne. One of the things you need to understand about AWS is this, what's called the Metadata Service. AWS is really designed for DevOps to be able to manage systems as they're developing them and quickly respond and have a quick turnover rate. The whole concept of DevOps just integrates perfectly with cloud-based systems like AWS. As part of that, one of the services that's very helpful is this instance metadata. What it does is it, on your EC2 instance, on your server, it gives you information about the system. It gives you information about what it's connected to and its permissions and all that kind of stuff. It also allows you to actually configure the server and make changes. This is a web server that's listening locally. It's actually listening. If you've ever noticed, if you try to get a DHCP address and you don't get one, the server's not listening. Windows will default to a 169.something.something.something address. That 169 address space is reserved for internal local host communications. So that's what this is. This is listening on a 169 address, which means it's only supposed to be accessible from the server itself. There's more information there if you want to read about it. So in this particular case, within that metadata, there is an API call called security credentials. And so what we know is that the attacker, we believe using SSRF, the attacker made an internal request to this URL. IAM stands for Identity and Access Management. That's the system that AWS uses to create user accounts and restrict who has access to what. So the attacker made a request to this URL, and they got this response. Now the stars are obviously just hiding the actual name. In the indictment, right, they didn't include the full name of the system and all this. That they did obfuscate some of it with stars, but whatever the name was, -WAF-role. So when they made this request, it said this is the role that this instance has. This is the level of permission, right? Think about like an Active Directory. This is the group that this user is in, effectively. With that, they were able to make another request, very similar, but they added the role on the end of it, and then that provides the actual credentials for that system. Now you think, why in the world would this give back those credentials? Well, think about, you're only supposed to be making this request if you're already on that system. So if you're already on that system, you already have authorization to do what that system has. This doesn't give you any more privileges. But there's a couple of things to note. In particular, by the way, this is not an actual key ID. If you try to use that, it won't be able to do anything with it. But what you can do, if you have an actual access key and the secret access key, you can use those credentials anywhere, not just internally. You can use them from the CLI, the command line interface. You can make API requests. And I bolded there, you can make them internally or externally. So we have a lot of stuff in AWS. We do a lot of stuff via the command line. Instead of me, going through the website and logging in and doing all the hassle of clicking a bunch of things and getting to the point where I want to upload files to my S3 bucket, I could very easily do that from the command line as long as I have that access key somewhere that I can connect with it. So hopefully you're following along. The attacker was able to make internal requests from the web server itself. Because of that, they were able to request URLs that should have only been accessible locally, which they were only accessible locally. And they were able to grab these credentials and pull those off. At that point, they used the list buckets command. Well, what's list buckets command? It exactly like it sounds. Think the ls command in Linux, or the dir command in Windows. This basically just says, here's a list of all the buckets, or here's a list of all the directories that you have accessible, that you can dig into. We know from the indictment that the attacker actually ran that command several times. So they were kind of trying to look through and figure out what they were doing. And then once they picked the one they want, then they use the sync command, which basically just says copy data from one place to another. In this particular case, they copied data from a particular bucket to their local computer, did that multiple times and got the buckets they wanted, all the data they wanted out of it. And then that's the end. That's data exfiltration. That's really all there was to it. One thing to note, very, very rarely do EC2 instances need the ability to list buckets, right? Like if you're writing an application, your instance is already going to know what bucket it needs. It's going to know, you're going to configure where the data is. So you can manually specify that, and you don't have to have the application go list buckets. It's also rare that a particular system or application is going to need access to a large number of buckets. I don't remember the number, but in this particular case, this instance had access to way more than maybe what was intended. And actually, if we go back, hold on, let me go back a few slides. So if we go back to this role, we don't know for sure, but it's fair to say that the WAF role is probably related to a web application firewall. That seems to be a pretty safe, they could have named it something different, but chances are this particular server that was compromised that had the SSRF vulnerability was serving some sort of WAF or web application firewall functionality. In that situation, it's very unlikely that that particular system needed access to any large amount of data at all. So at that point now, the attackers just rolling in the dough, having a great time, you know, living it up, buying their own private island, or, you know, not so much. In this particular case, and I want to be fair, this person seems to, you know, maybe have had some mental issues and was on a bit of a downward spiral, you know, according to some folks. And this isn't about that. I don't want to go talk about that. But what we do know is that they really didn't try to cover their tracks at all. They didn't try to obfuscate where they were coming from. They posted data on GitHub. They bragged about it on an internal Slack team. And then what happened was, and this is kind of some pieces I've put together. Somebody anonymously notified CapitalOne and said, hey, some of your stuff's over here on GitHub. You might want to check this out. I don't think we know for sure that came from Slack, but there's been some other internal chatting just from different groups that suggests somebody on that Slack team, you know, gave that out. So just be aware of that. If you're one of those big bad black hat hacker types and you think you're trusting in other people, be careful who you trust with your ill-gotten gains there. So let's talk a little bit about some of the security controls to put in place to limit the risk. And it's important to understand, if we go back to that picture about usability versus security, there's always a fine line. Things can never be perfectly secure. And no matter what level of security we add, it's going to be some level of hindrance to the usability. So we need to balance that and figure out what's an appropriate level of risk. In this particular situation, it's really kind of complicated. Understanding all of the ins and outs of AWS and S3 buckets and all the different components and how things play together and what roles need to be created and what permissions need to be assigned to that roles. It's really a mess. I can't, part of me wants to imagine that this picture is fake. I don't know. If somebody can, I found that on Google. If somebody can find a source for that image, that would be awesome. I would love to know that that's a real place. But unfortunately, that is very similar to a lot of complex applications that we put out there today. And part of the reason, I'm going to go on a little bit of a political tirade here. Kevin and I argue all the time about the OSI model versus TCP/IP and all this stuff, and a lot of it's for show, and we have a lot of time, a good time. But I really believe that part of the problem with S3 buckets in general and the miscommunications and misunderstandings, and in particular situations like this, is a lack of understanding of the networking model idea. Just real quickly, if you're not familiar with the OSI model, it was a model design that came out, I want to say in the 80s or at least in the late 70s, to kind of outline the concepts of networking. You know, starting from the bottom where you've got physical wires up to the top where you have application layer stuff. And a lot of networking folks tend to use the OSI model to help troubleshoot and figure out, okay, this is working, let's move up the stack until we get to the point where something's not working and troubleshoot. What I have found personally is that people that are formally educated, that went to college for computer science or whatever, they tend to think in terms of the OSI model, whereas people that hit the ground running and just jumped into an IT role and learned, you know, in the trenches, they think in terms of implementation of TCP/IP, of specifics. What happened was, and I know this is probably more history than you care about, but go with me for a second. Once TCP/IP became so popular, you know, we're talking early 90s, late 80s, early 90s, all of the other lower level implementations kind of went away, right? Especially if you remember gaming back in the early 90s, you may remember like the SPX protocol, and you know, the Apple had their own special stuff, and there were some different protocols out there that kind of were instead of TCP, but eventually those all went away, and basically layers, you know, 2, 3, and 4 pretty much became standardized on ARP and TCP/IP. Because of that, folks really don't have to think about it that much. Where we are now is that people that deal with networking understand networking really well. People that deal with applications understand applications really well. People that manage systems understand systems really well. And then some people have to balance all of that and figure out. But that group that figures all of it out tends to either work in smaller organizations, or they just don't have a deep dive knowledge into all of the different areas. Part of this also is to blame, and I'm going to tie these two things together, is the concept of DevOps. Now, I'm not saying DevOps is bad. Please don't crucify me. I'm sure I'll see the attendees rate drop here right as all the developers start killing me. The concept of DevOps is awesome. We gained so much speed and flexibility and the ability to service business needs. But what happens is we've replaced, in a lot of cases, sysadmins and network operators, and we've lost some of that really granular level of knowledge about their trade. And it's been handed over to developers who, for the most part, are just used to things working, right? I got the system, I'm gonna deploy stuff, and I'm gonna make it work. You know, Kevin, I was talking to him last night, and he gave the example of, you know, talking with a developer who's trying to figure out why their application doesn't work, and you know, Kevin's helping him troubleshoot, and he's like, well, you know, did you set the environment variable, you know, for the path? And the dev was like, I don't know what you're talking about, just make it work so that my application will do its thing. You know, they know their particular areas and maybe not all of the other side things. I think that's partly to blame in this situation, because the AWS model is a little bit different, and not just AWS, but the cloud model is a little bit different. We're building out new technologies, we're building out new interactions on the network stack that make sense if you think about it in terms of OSI, but maybe don't fit quite the same into the TCP/IP model that we're used to. And so a lot of things get missed, a lot of things that people don't think about. The whole idea of having a local host listening web server that gives you information not only about the network and the instance, but about the roles that are assigned via, you know, an integrated IAM interface. Like that doesn't fit anywhere under traditional networking and sysadmin stuff. So there's a lot of new stuff there that we're just trying to figure out, and honestly, what it comes down to is education. People just don't quite understand what they don't understand the power of the tools they're using. So let's talk about a couple of common themes here across all of these breaches. These are things we keep hearing over and over again. One is a lack of training. We have people, you know, AWS makes it very easy. And, you know, I started this webinar saying that, hey, if you haven't used AWS, it's real easy to jump in and start messing with it and figure stuff out. The problem is it's real easy to jump in and start figuring stuff out. Getting up to speed with training and understanding all of the ramifications and all the different functionality, that takes some time. And especially at the business level and at the enterprise level, we need to make sure that the people who are doing these things have the training they need. We can't assume, well, you've been doing sysadmin stuff or network stuff or development stuff. You've been doing that for 30 years, and so you can just figure this out. There's more training that needs to happen. Auditing is part of it also. I don't know how many times people make a change to a system either as part of troubleshooting or trying to make something work or whatever, and they say, oh yeah, I'll go back and change that after we verify that was the issue, and then they forget and it never goes back. Or maybe somebody missed a step as part of an implementation and nobody ever goes back and checks it. Auditing is crucial with these systems because of the increased level of integration. We have to have configuration standards of saying, this is how this is supposed to be configured, and we're gonna audit against those standards and make sure they really are. And then testing goes along with auditing, kind of the next level of saying, okay, we've checked this, but we need to actually verify. We need somebody to actually try to turn that doorknob and make sure that thing actually works. Not just works the way it's intended based on the configuration standard, but works the way that the initial developer thought it would work when they wrote out the standard, right? When they say, this is how we're going to configure this, they may have a misunderstanding of the permission. Or even worse, perhaps the permissions have changed since that system was first deployed. Maybe AWS rolled out some new updates. And so you need to have that regular testing to make sure that things continue to work the way you think they do. The lack of defense in depth is another issue that is pretty consistent across these cloud misconfigurations. You know, people say, well, I have this checkbox and that checkbox control is going to prevent this, so I'm good. You know, the concept of defense in depth is that, you know, you need to plan ahead for that specific security control to fail. And you need to say, what happens if that fails? How else are we going to detect this? Maybe your secondary control is not a preventative control. Maybe it's a detective control, and we're going to get alerts on it if that happens. But you need to think through that process for each of the different types of threats and risks that you deal with. And then the last one is the lack of the principle of least privilege, or maybe an insufficient level of principle of least privilege. It's very common, and this, everybody does this as we're building systems, to say, you know what, I just need this to work. Let's open it up, and then we'll we'll fine tune it later, and we'll make the permissions more granular. But it seems like with web-based stuff, with cloud-based systems, there's less and less of a focus on, hey, I only want to give this the access that it needs to do what it needs. I'm going to open it up, and this will be fine because nobody should have ever have access to that system in the first place. Now, I want to give you some specific recommendations for S3. The first one is configure encryption. That's part of the, creating a bucket. It gives you encryption options. There's 3 or 4 different options that you can choose, and you should absolutely read up on those and say, which one should I choose? But that's kind of a no-brainer. If somebody else, if a third party, whether it's Amazon or whoever, if somebody else is going to host a system for you, make sure you're using encryption. So if that server, if that hard drive walks away, with a janitor, you haven't lost your data there. The next one is that each EC2 instance and each application should have its own IAM role. So, we talked about earlier how the WAF role that was used in this particular attack had access to a bunch of stuff. They had obviously created an individual role for that function, whether it was for that instance to that application. I don't think we know for sure, but they had limited that. You need to think through, how many different roles do I need to have? One for each instance, one for each application. To some degree, that needs to be based on the idea of, we're going to segment it by groups. Systems that have sensitive to critical data need to be maybe a little bit more granular, whereas systems that are less important or less critical, maybe they don't need quite as level of granularity for the number of roles. But you need to think that process through. You also need to limit the S3 permissions to only include those required roles. So in this particular case, with CapitalOne, that WAF role, there's no reason it should have had access to a lot of the buckets that it had access to. Somebody needed to go through the S3 permissions and say, okay, only these particular roles have access to this bucket. This instance over here needs to access these files for a particular business case. We've documented that. We added the permission. This application over here, it interacts with these data. So we've documented that, and we've allowed that. Again, you need to think through that. You also need to restrict roles as much as possible with certain, AWS calls them condition restrictions. The idea is that that WAF role. My guess is, now I obviously have no insight into the internals of CapitalOne, but my guess is there is almost no possible reason that the credentials for that WAF role ever need to be used externally. There's no reason that a user connecting to the system from somewhere on the internet via the CLI or the API, there's no reason for them to use those credentials externally. So that should have been able to be restricted. Now the problem is, and I've got a quote here, I didn't include the guy. I saw this as a tweet yesterday. One of our coworkers retweeted it. There are 5,985 permissions, and only a little less than half of them actually let you limit to restrict the conditions. So of all those privileges, 42%, I'm sorry, over half, just over half allow you to restrict it. 42% have no condition restriction, meaning the only thing you can use is wildcards. Now, remember when I talked earlier about the use of wildcards being used everywhere? This is partly why, as you go through saying, okay, what does this thing need access to? Here's my 6,000 options. It can be kind of overwhelming. And it is a responsibility that takes some time to go through and say, okay, specifically what's required, what's not, and then how can we restrict those? I do know, I have seen that AWS over time has increased the granularity of the restrictions that can be set. So, if something doesn't allow you to restrict it to a certain IP address or a certain time frame right now, in 6 months they may, especially after stuff like CapitalOne happens, they may increase some of that kind of stuff. And then the last one here is to enable CloudTrail, which is the logging functionality, the logging system within AWS, and have it set up to monitor for malicious activity. By default, and this is one of the weaknesses of S3, and there's a reason for it. It's fairly expensive in terms of resources. Logging is disabled by default. So the ability to log who accesses a system, when they accessed it, what role they used, I say a system, to access data within the S3 bucket, that level of access must be turned on. And then also object level access. Object level means down to the specific object within the bucket, a specific file, a specific link. Whoever accesses that and modifies it and changes it, keeping track of that level. Those are 2 logs that need to be turned on and enabled. And once you have that, then you can go through and be able to look back. Now, we do know that CapitalOne obviously had some of this stuff configured. They had CloudTrail running, they had, or in some form, they had this level of logging. Because of the level of detail that was in the indictment, they would not have had that if they didn't have the monitoring. So that's at least a good side, a plus on their end. Some other considerations to think about. These are things that, as I was thinking through, I was like, okay, if I were the CISO at CapitalOne, what could I have done? Here's some other things. Secure developer training is critical. And yes, I totally say that as a provider of secure developer training. I'm actually going to LA next week to teach a training class to a company. Developers are not trained in security. No offense to any developers on the call. I think they'll probably hold their hand up and agree with me. You know, I got a 4-year degree in computer science. I touched maybe 15 languages while I was there. Got pretty proficient in a couple of them. And I don't remember a single class, maybe not even a single section in a book on security. It just wasn't taught. You know, if you look at Stack Exchange, or, you know, look at all the tutorials online, security is the last thing that people learn when they're learning development. So we need to do a better job as an industry and as individual corporations. We need to focus on making sure our developers understand security flaws, understand the developer techniques to prevent those flaws, and how to avoid that. In this particular case, if the developers of this tool understood SSRF and had prevented it, we wouldn't have even, you know, none of the rest of this would have happened. We wouldn't even be here talking about it. Logging and monitoring are critical. Again, SSRF should have been easily detectable if you have significant enough logging and monitoring. As soon as that, you know, as soon as that first instance started making connections that were unusual, started making connections to other places, that easily could have detected that. And then also, you know, like I mentioned, CloudTrail easily could have detected that role was being used externally if they had configured that. And then the last one, and I say this with some hesitancy because this is a hassle. Consider splitting production systems across several accounts. Especially if you're a large enterprise, if you've got some pretty significant stuff, if you've got really sensitive data, it might be worth having multiple AWS accounts and having critical systems that have to access certain data in one, systems that are maybe more ancillary that don't necessarily have access to the data in another. That gives sort of a hard boundary between the two, and it will prevent you from making misconfigurations or missing steps that can open this up. So those are just ideas of things you consider. I didn't mention on the logging and monitoring. I'll throw there too. I added and alerting. You've got to make sure that you're alerting on critical things. When, you know, you need to think through, hey, what possibly could happen? Like, what would an attacker do? What types of steps would they do if they were exploiting certain flaws? And what would that look like? Okay, now can I generate alerts if I see those types of logs? That needs to be thought through really well. A lot of organizations don't do that well. Target is the great example. You know, don't be a Target. Target's third-party HVAC vendor was compromised. The attackers went in through the VPN and got into the network and then pivoted through the network to the point of sale. Throughout that time, Target got a large number of alerts, but nobody was watching them. You know, so we need to do better as an industry there. The last thing I wanted to share with you before we end is just some specific tools that can be helpful. AWS has actually put out some really good tools to help with this process. I know it seems burdensome on the surface. The AWS policy generator allows you to specify, okay, I need this specific resource, this instance or whatever, to have access to this whatever. Maybe it's an S3 bucket. And here's the roles that need access to it. And you can go in there and you can put the specific requirements, and then it'll auto-generate the policy for you and make that easy to do. There's also a policy simulator that lets you say, okay, I'm going to put this policy in place. Now let me test this out. Does it really prevent this from accessing that? Does it work the way I think it does? Those tools do require a little bit of knowledge. You know, you need to understand what you're doing, but they can be really helpful. Duo Labs, that do the two-factor auth, they've also put out some cool tools on this as well. Cloud Mapper basically creates a map. If you've ever seen something like Bloodhound or one of these tools that makes maps, it basically makes a map like that of all of your AWS resources and demonstrates, hey, this system has access to that data, this system has access to this role, vice versa. You know, you can see kind of an outline, and it makes it fairly easy to detect, hey, that should not happen over there. You do need to be careful with false positives with stuff like that. Anytime you're depending on the human mind to visually, you know, find anomalies, it's a great way to find stuff that really sticks out. It's not a great way to find stuff that's a little bit harder to see. But that's still a great tool to use. And then Cloud Tracker is another one, again, that provides some of the more granularity to the ability to monitor what has access to what, and what changes are being made and that sort of thing. With that, a couple of references there. I'll leave those in the slides, and they're on the recording so you can see them later. And I'm going to open up for questions. We got about 9 minutes left, just to see if anybody has any questions. Feel free to throw them in the chat. I've got one here that came across. I actually saw this. So yesterday, I don't want to get too deep into this. Robert Graham tweeted saying that defense in depth isn't a real thing. It'd be awesome if he's on here. He's not on here. No, okay. So Robert Green's close. Defense in depth isn't a real thing. I understood the argument he was making, but I disagree with the way he was making it. He was referring to, again, this is kind of complicated. He was making a semantic argument about the naming and what we call it and how we respond to it. The idea of having, you know, a control that covers the same thing or similar thing when another control fails, I still think that's critical. And I don't think that's quite what he was ranting against. So, yeah, Twitter arguments can be interesting. Any other questions? Would you recommend the use of Dropbox, Box, etc. services to store critical company data? I'm always hesitant to say yes, because tomorrow somebody will announce a a big breach in Box or Dropbox. I will say that I'm not a big fan of Dropbox. The reason, and I haven't looked at Dropbox in 7 or 8, maybe 10 years. Early on, Dropbox had some pretty significant issues, and when they were confronted with it, they tried to respond in ways that demonstrated they didn't quite understand the implications of the security decisions they had made. And that just set a really, like, that kind of made my back itch, right? I'm just, I don't like that. So I've tried to stay away. Now for personal stuff, whatever, I would maybe avoid that. But with that saying, in the last decade, maybe their security has improved significantly and maybe it's no concern. I know a lot of people use Box. I know a lot of people use OneDrive. Here at Secure Ideas, we use Google for our storage. I'm not against it at all. I think you need to understand and think through the threats and the risks and the changes that are posed that you wouldn't have if you were hosting something like that yourself. You know, there are different threat models. The example earlier, I talked about Chris Vickery and his ability to, you know, once he found a particular flaw in S3 that a lot of people were doing, he was able to scan the internet for these vulnerable S3 buckets and connect to them. That same sort of thing, maybe not the exact same attack, but that sort of attack could happen with Box. If somebody were to find a flaw in Box, it's possible they could scan the entire implementation of Box and discover weaknesses that allow them to access your data. With that said, we all have to trust third parties. That's the way we do business. So that's more of a business case decision of, you know, what controls am I putting in place there. Other questions? All right, well, it's, what are we, 1:55? We've got about 5 minutes left till the top of the hour. I'm gonna go ahead and stay on the call. So if you have questions, if you wanna stick around, feel free to do that. Or if you have something, if you wanna contact me directly, my contact list info is there. I appreciate everybody's time and hope you have a good rest of your day. Thanks a lot. So Darren asked here, says in the news today, it mentioned that the hacker may have hacked 30 companies. Do you suspect the same technique could have been used on all of them? Yeah, I saw those reports, and I don't have any particular insight. My guess would be that's very likely. If I wanted to speculate, it's very likely that whatever web application firewall that CapitalOne was using was not something internally developed. It's very likely that it was a custom off-the-shelf tool that they deployed. It's possible, I don't want to say likely, but it's possible that that was even a standard AMI that could be deployed through AWS. And if that's the situation, then it's likely other companies would have deployed the same tool. So what we see often is that once an attacker finds a flaw in something, they start scanning the internet for other instances of it to find, vulnerable victims. I don't know, by circumstance, I guess. So that's entirely possible. Is that this person found an SSRF vulnerability in a particular WAF. And they knew, hey, we do know that this person used to work for Amazon, and so they understood the concepts and some of these things a little bit better than others. It's possible that they said, hey, let's scan and find other people using this WAF, and then attack the other companies the same way. I think that will probably come out in time as the investigations go further and as the criminal case and whatnot happens. On a side note, as we're waiting for other questions, if anybody else has, that's a great example of why your server response headers should never provide more information than you need. If I can scan your website and get a list of, hey, this is running this server, this version, or this WAF or whatever, there's no reason for those systems to identify themselves in server response headers. So, if I'm an attacker and I discover a particular flaw in this WAF, all I have to do is start scanning the internet, looking for demonstrations or examples where I get those response headers for that WAF, and now I have targets. So that's another defense in depth method there to protect yourself. All right, well, we're hitting the top of the hour. We're going to go ahead and cut off the recording. But like I said, if you have any further questions or comments, shoot me an email. I'd love to hear from you. Thanks, guys.